Hello. I wanted to welcome everyone to TA's National Conference, TIC-CON. We're so glad that you have joined us. Before we begin, I'd like to introduce myself. My name is Jennifer Gonzalez. I'm the accounting manager at the Tourette Association of America, and I'll be helping to moderate this session. Send me a direct message in the chat if you need any assistance. And I also wanted to inform you that we are offering transcriptions and translations for our sessions, and please see the chat for more instructions on that. So I would like to introduce our speaker for today, Dr. Sharon Anavi-Goffer, PhD. Sharon Anavi-Goffer is Honorary Senior Lecturer, School of Medicine, Medical Sciences and Nutrition, Institute of Medical Sciences, University of Aberdeen, UK. Her research is focused on the pharmacology of cannabinoids and directed at drug discovery of cannabinoids to treat Tourette syndrome and schizophrenia. She received awards of research grant awards from the Tourette Association of America, translational grant awards from the Chief Scientist Offer of Israel, and Young Investigator Awards at the Charles E. Smith Research Award in honor of Professor Joel Elks from the National Institute of Psychobiology in Israel. Medical Cannabis Agency, She has trained physicians and pharmacists on the pharmacology of cannabinoid to the Israeli Medical Cannabis Agency, Ministry of Health, Israel. Dr. Anavi-Goffer is a member of the Clinical Advising Committee to the Tourette Syndrome Association, Israel TSAI, and a member of the International Advisory Consortium on Medical Cannabis-Related Drugs for Tourette and Tic Disorders, TAA-US. Dr. Anavi-Goffer is the founder and CEO of Freed Pharma, which aim to bring novel drugs to patients with mental health diseases. Dr. Anavi-Goffer graduated the BioM and Smile Biotech Bootcamp program with Merck and graduated the GRIT International Female Accelerator Program, enabling entrepreneurs in biotech to scale up drug development from the lab to the market. Dr. Anavi-Goffer also acts as a private consultant of psychoneuroimmunology to improve people health, improving their life quality and well-being. And I'll turn it over to Dr. Anavi.
Thank you, Jennifer, for the lovely introduction. And hi for everyone from Israel. I hope you can hear me well. And just to let you know, you can put your question in the Q&A, and I will address the question in the end of my talk. So I would like to start with some background, and for those of you that heard Elia's talk, he gave a fantastic background, and I will continue from there. And for those who didn't or missed it, I will give some short background. So THC, delta-9 THC, that I will abbreviate as THC, is the psychoactive compound in cannabis and is known to reduce motor tics in individuals with Tourette, as Elia presented. However, THC affects brain development and it can increase anxiety and induce psychosis. So Elia gave a really good presentation of this. And in terms of pharmacology, THC has similar affinities for the CB1 and the CB2 cannabinoid receptors. This is the only two receptors that we know today that are cannabinoid receptors. So for a very long time, it has been assumed that the actions of THC are via the CB1 receptor only. And this is because CB1 is highly expressed on neurons. However, the involvement of the CB2 receptor on motor tics has not been investigated. And why is this important? This is because the CB2 receptor is highly expressed on cells of the immune system, but is also expressed on neurons in the brain. And moreover, CB2 expression is upregulated in some diseases. So in this study, we asked, can the CB2 receptor modulate motor tics? And is this mechanism associated with sex? And is this mechanism associated with age? And after my talk, I invite you to read the full story in our published papers. So first, we want to understand what kind of evidence we have for functional CB2 receptors on neurons in the brain, and what do they do there? So CB2 receptor is expressed in the striatum and the brainstem, where it regulates dopamine release. And I gave you here some evidence that we have from preclinical experiments. So in adult male mice, JWH-133, a CB1 receptor agonist, reduces adult locomotor activity. And it also reduces cocaine-induced locomotor activity. And HB308, another CB2 receptor agonist, reduces dyskinesia-like behavior in a model of Parkinson. But the same compound has no effect on locomotor activity of adult female mice. So it appears that there is a complex mechanism for the control of motor activity by the CB2 receptor, and that the sex contributes to it. So we looked up for an animal model for Tourette syndrome to investigate the effect of HB308, a CB2 receptor selective agonist. And in 2008, Wong suggested that high serotonin level may dysregulate dopamine release in patients with Tourette syndrome, causing spike-dependent dopamine release, and this leads to tics. So we decided to go for an animal model of serotonin-induced motor tics. And in this table, I summarized for you the advantages and disadvantages of this preclinical model. So we use DOI, and the full term is abbreviated at the title. So I will just call it DOI for this compound. DOI is a potent 5-HT2A2C receptor agonist. It induces head twitch response that I will abbreviate as HTR, ear scratch response that I will abbreviate as ESR, and grooming behavior in one model. And this is the big advantage of this model. So this is resembling head tick-like, urge-like behavior and caudally located motor-like tics, respectively. And in the bottom below, you can see a graph where we use Pimozide, a second-line treatment, to validate the model. So in red is DOI, and in the blue lines are with DOI with Pimozide, and you can see that Pimozide reduces the HTR response of DOI. But what is the disadvantages of this model? So first, there are no vocal tics in this model. And second, because this is a systemic administration, it actually mimics serotonin transmission in different brain areas. So for example, it reduces stress like SSRIs. In this slide, I summarized for you data that we got with increasing doses of DOI. So DOI induces motor-like tics in adult mice. And you can see from your left, the HTR responses, in the middle, the ESR responses, and on your right, the grooming behavior. And what you can see is that when you're increasing the dose of DOI, the motor-like tics are gradually increasing. And you can also see that there is some basal activity. So next, with the support of TAA, we studied the effect of THC and CBD, the non-psychoactive compounds in cannabis that Ilya mentioned earlier. And so from the left, you can see the results with THC on HTR. In the middle, the results of ESRs, and on your right, the results of grooming behavior. So we gave DOI and gave increasing doses of THC. And what you can see on your left, the THC caused a reduction in HTR, but this is only up to 34%. And at this dose, the mice showed catalepsy. And catalepsy is something that can be defined as a decreased motivation towards movement, also induced by cannabis. So in the next two graphs, you can see that THC reduces ESR, the urge-like response, and grooming behavior, the caudally located motor-like tics. So based on these results, we compared the effects of THC in juveniles and adult mice. So we did the same experiment as you saw before in juveniles and young adult mice. So on your left are the results in juvenile mice, and on your right is the results with young adult mice. And we calculated the results and show them as graph, and calculated from this graph the ID50. And the ID50 can help physicians to decide what is the optimal dose for patients with Tourette's. So as you can see, the ID50 for caudally located motor-like tics and for urge-like responses at the bottom panel are quite similar for juvenile mice. But when we looked at the effect of THC in young adult mice, we got differences in the ID50, and they are quite big between the caudally located motor-like tics and urge-like responses. So we hope that with these ID50 values, we will help physicians to decide which dose of medical cannabis to give young patients with Tourette, so that children and adolescents will not be overdosed. And for physicians, you can see the differences in the ID50, and in the published paper, we provided the translation for equivalent human doses. So next, we studied the effect of CBD and discovered that CBD increases motor-like tics. So on your left are juvenile mice, and on your right are young adult mice, and we gave increasing dose of CBD. And what you can see that CBD on its own induces motor-like tics, a significant HTR both in juvenile mice and in young adult mice. So taking CBD may increase the risk to develop Tourette-like symptoms, and CBD may enhance the frequency in pediatric patients with existing motor tics. So next, we studied the effects of CBD in the presence of DOI, and you can see the results here. So on your left are central motor-like tics, the HTR. In the middle are urge-like responses, the ESR. And on your right are the peripheral motor-like tics, the grooming behavior. And as you can see, CBD had no effect on HTR, no effect on ESR, and no effect on grooming behavior. So we discovered that CBD has no effect on 5-HT2A2C induced motor-like tics. And this suggests that for patients with Tourette syndrome, the dose of CBD should not be increased in medical cannabis extracts. So the results with THC and CBD are published, and we invite you to read the full paper. So next we asked, can the CB2 receptor modulate motor tics? And our specific objectives were, what are the effects of AG308, a selective CB2 receptor agonist, on motor-like tics? Second, what are the effects of motor-like tics of AG308 in the presence of DOI a highly potent agonist of the serotonin 5-HT2A2C receptors? And third, what are the effects of AG308 on motor-like tics on CB2 receptor knockout mice? So on your left, you can see the results with AG308. At the top panel is HTR and the bottom panel is ESR. And what we found is that AHU significantly increased HTR response in mice, in juvenile mice. And similarly, we found that AG308 increased ESR response in juvenile mice. So we wondered if another CB2 selective agonist can mimic the effects of AG308. And we selected beta-caryophyllene, that is abbreviated here as BCP. And what you can see at the top panel, that BCP increased HTR, and BCP at the bottom panel increased ESR. So two selective agonists, CB2 selective agonists, increased HTR and ESR. So we discovered that stimulation of the CB2 receptor significantly increases motor-like tics in juvenile male mice. And please mind that BCP is also found in cannabis. So we wondered if AG308 reduces locomotor activity or how it is affecting locomotor activity in the same mice. So we took the mice and gave them AG308 and tested them for ambulation and rearing behavior on your left. So as you can see on your right, on your left, that AG308 significantly reduced ambulation behavior. And on your right, AG308 significantly reduced rearing behavior. And this was an acute dose and in a systemic administration. So what we found is that the systemic administration of AG308 reduces ambulation and rearing behavior. And collectively, these results suggest that AG308 reduces locomotor activity, but significantly increase motor-like tics. So the phenotype that we got is hyperactivity, no hyperactivity, but motor-like tics. So collectively, these results of this set of experiments suggest that the increased HTR and ESR in juvenile mice that was induced by the CB2 receptor agonist suggests that stimulation of the CB2 receptor may generate motor tics in children. So next we asked, are there sex differences? So to address this question, we tested the effect of AG308 in juveniles, males and females. So on your right, on your left is juvenile males and on your right are juvenile females. And as you can see, AG308 increases HTR responses significantly. But when we looked at females, we found either no effect or a minor effect compared to the effect in males. Then we looked at basal grooming behavior. And so again, on your left is juvenile males and on your right are juvenile females. And as you can see, AG308 had no effect on juvenile males, but significantly reduced the grooming behavior of juvenile females. So this means that AG308 has different responses in males and females. And then we looked at the effect of AG308 in the presence of DOI. So we took the lowest dose, 0.2 milligram per kilogram. And again, on your left is males and on your right is females. At the top panel is HTR and the bottom panel is grooming behavior. And as you can see, AG308 at 0.2 milligram per kilogram had no effect on HTR and no effect on grooming in males. But when we looked at females, AG308 significantly reduced HTR and significantly reduced grooming behavior. So what does it mean? This means that AG308 at 0.2 milligram per kilogram significantly inhibits DOI-induced HTR and grooming behavior in females, but not in males. So the implication of these results are that CB2 receptor stimulation may possibly reduce the frequency of caudally located motor tics in girls. And what this means is that this suggests that the CB2 receptor contributes to the skewed ratio between boys and girls with Tourette syndrome, increasing the prevalence of Tourette syndrome in boys. So next, what we did was to increase the dose of AG308 to 1 and 5 milligram per kilogram. So again, on your left is males and on your right is females. And what you can see at the top panel is HTR and the bottom panel is grooming behavior. And as you can see, at 1 and 5 milligram per kilogram, AG308 significantly reduced the DOI-induced HTR and the DOI-induced grooming behavior in males. And similar results we got in females. So AG308 significantly reduced HTR and significantly reduced grooming behavior, DOI-induced grooming behavior. So in summary of this set of experiments, we found that AG308 at 0.2 milligram per kilogram inhibited DOI-induced motor-like tics only in females, whereas AG308 at 1 and 5 milligram per kilogram inhibited motor-like tics both in males and females. So we addressed the question, can the CB2 receptor modulate motor tics? And the answer is yes. And next question was, is this mechanism associated with sex? And the answer is yes. So these results collectively suggest that CB2 receptor modulate 5-HT2AC induced motor tics in males and females. And this further supports that the CB2 receptor contributes to the skewed ratio between boys and girls with Tourette syndrome. So the next question was, is this mechanism associated with age? And this is because the CB2 expression is developmentally regulated, with the expression level being high after birth and gradually decrease in the adult brain to a very, very low level. So next we tested juvenile males and young adult males, and to see if there is a difference in the effect of AG308 on DOI-induced motor-like tics. So in juvenile males, the top panel is HTR and the bottom panel is grooming behavior. And as you can see again, that AG308 significantly reduced HTR and grooming behavior in juvenile males. But when we looked at young adult males, we found no significant effect of AG308 on DOI-induced HTR and no significant effect on DOI-induced grooming behavior. So the conclusion from this experiment is that the CB2 receptor mechanism that modulates 5-HT2A2C induced motor tics is associated with age. So next, we wanted to see what are the effects of AG308 in adult mice. And we took adult male mice. So on your left are CB2 knockout mice, and on your right are adult mice, male mice. The top panel is HTR, and the bottom panel is grooming behavior. And we expected to find the similar results to young adult mice, that AG308 will inhibit DOI-induced motor-like tics. But as you can see in adult mice, there was no effect of AG308 on DOI-induced HTR or significant effects or reduction in the effects of grooming behavior. That was actually increased. And in the CB2 knockout mice, we expected to find similar results to the adult mice, but we actually found that AG308 significantly reduced HTR and had no effect on grooming behavior. So we expected to find similar results in female mice. So on your left are adult female mice, CB2 knockout mice, and on your right are adult female mice. And as you can see, now that we gave AG308, it actually significantly increased ESR and grooming behavior in female mice. And more surprising was to find similar results in CB2 knockout mice. So AG308 significantly increased ESR and grooming behavior in adult mice that are CB2 knockout. So what does it mean? This means that AG308 has an off-target effect, which increases 5-HT2A2C induced motor-like tics in adult female mice. And discovering what is the target of AG308 that modulate motor tics in adult females will promote the development of new drugs for motor tics. So next we did an RT-PCR study. And in this diagram, you can see the pathway of synthesis and degradation of the endogenous cannabinoid ligands that our body produce and stimulate the CB1 and CB2 receptor. And in circles, I circled the two endocannabinoids, the two main ones, 2-HG and anandamide, which is abbreviated as AEA, and the two enzymes that degrades them. So FAAH degrades anandamide, AEA, and MAG lipase and ABDH6 and 12 degrades 2-HG. So what will happen if there is a change in the catabolic enzymes expression? So if the degradation enzyme will decrease, it means there will be more endogenous ligands in our body. So I summarized it here. You can see a reduction in the catabolic enzyme expression level will increase 2-HG and anandamide levels. And this is the results. So in red are the expression level of after DOI induction, and in gray are the control groups. The top panel is CB2, and then ABHD6, and then FAAH expression, and then CB1, GPR55, and FAAH. And on each side, you can see the left and the right cortex. So we decided to focus on the prefrontal cortex, and this is because a genome-wide association study found significant mutations in patients with Tourette in this area. So as you can see at the top, I see in the top circle is the DOI increased the expression level of mRNA of CB2 receptor. And then the next circle is ABHD6. You can see that DOI significantly reduced the expression level of ABDH6. And similar results we found with FAAH. So DOI significantly reduced FAAH expression. But what was really surprising that all this happened only in the left cortex, but not in the right cortex. So what does it mean? Is that the exposure to DOI, a potent 5-HT2A2C receptor agonist, causes lateralization in the expression level of elements of the endocannabinoid system. And what this means, this may contribute lateralization in the endocannabinoid system may contribute to the lateralization in single hand finger movement found in children with Tourette syndrome, causing a shorter movement time and more errors. So 2-HG and the endocannabinoids may be released as acute or sustained. So in animals, an acute release of 2-HG stimulates the CB2 receptors on dopaminergic terminals, inhibiting dopamine release. Whereas if we looked at sustained release, a clinical study found increased 2-HG and anandamide levels in the CSF of patients with Tourette. And all the references are in the published paper. You can see them later. And our RT-PCR study found that stimulation of 5-HT2A2C receptors induces a reduction in FAAH and ABHD6. And this may explain the increase of anandamide and 2-HG levels in patients with Tourette syndrome. So if we work out all this information, this suggests that correlating 2-HG levels from brain versus the CSF versus single hand finger movement, this may help to diagnose patients with Tourette syndrome. And finally, the implication is that developing CB2 receptor inhibitors to treat patients with Tourette syndrome will form a novel drug treatment, and this is what we are focusing on. This is our target. So finally, I would like to thank Victoria and Veronica, my students, and Ian, Roger, and Peter, my collaborators, and to the Tourette Association of America for funding our studies. And thank you for your attention. And now I will take the Q&A question. So can you please show or describe what the HTR looks like and comment on the phase validity of the HTR model of tics? I suggest, I think there are videos that you can see HTR in mice. There will be probably different from HTR in rats. And I think that because pimozide and THC, and this is what we were showing, the validation of this model is that pimozide and other drugs and THC reduces HTR, both in patients and in animals. And yes, earlier there are new publication from Muller 2022 on the effect of medical cannabis. Thank you. Can you speculate the mechanism by which CBD increased motor-like tics? We discuss it in the paper. So CBD is pleiotropic ligand, and it acts on different receptors, including 5-HT1A and 3. So if it's possible, I will refer you to the full paper. We fully explain it. And also it acts as to antagonize the effect of endogenous ligands. So this will be the possible mechanisms. There were other things on the chat. What is CB2 exactly? CB2 is a receptor. It's a protein that is expressed on cells of the immune system and on neurons and on glia cells. Do you say THC is non-psychoactive? No, the opposite. THC is the psychoactive compound and CBD is the non-psychoactive compound. Great questions. Clarifying THC versus CBD would be good. Thank you. This is what we did. And actually, the results in patients with Tourette syndrome that Ilya presented earlier actually confirm our results in mice. What is it? What are they administrating? CBD or THC? Editable capsule smoke. So this is not experiments in patients. This is our experiment in animals. So all the drugs were injected IP. This is all the questions we had so far. So if there are no more questions, thank you very much, everybody, for attending. And if you need to ask anything else, you can email me. Thank you.
Thank you. Thank you, everyone, for joining us. There is a link in the survey, a survey link in the chat, if you wouldn't mind to take a minute and answer those questions. And please visit the lobby for TAA resources and other valuable information, and enjoy the rest of TIC-CON 2023. Thank you.
Thank you.